The closest star to the Sun is a bit more than 4 light-years away from us. However, if you could somehow travel to the very center of our Milky Way galaxy, you'd be surrounded by an astonishing number of stars, over 1,000 stars in every cubic light-year. Imagine being in a place where there are that many stars in every direction you look. It would be truly overwhelming. Surprisingly, when we try to observe this densely packed star region at the Milky Way's core with regular visible light telescopes, we can't see much due to all the gas and dust blocking our view. But here's where infrared telescopes come to the rescue. They can see through this material and help us to make out those countless stars, providing us with valuable insights into what's happening in the heart of our galaxy. And the greatest, most remarkable infrared observatory we have is the James Webb Space Telescope. The James Webb Space Telescope, or JWST, is helping us to find answers to some of the biggest questions about space. Hubble showed us what space looks like today, but JWST's main job is to tell us how space started. So let's get into this video and see what we've learned about the vastness of it so far.
I understand that I am a collection of atoms that came from the hearts of stars that briefly comes together and forms planets and people and everything that's in our world. And then, I was observing one night at Mount Palomar where we were observing supernovae, and supernovae are the explosions of an entire solar system. A whole solar system is destroyed, a star and all of its planets. And our telescopes are so good now that at a typical night at Mount Palomar, you see about 20 of those a night. You see 20 entire solar systems ripped apart every night. So we're here very briefly. We're little collections of atoms that come together and scatter, and then form other things, and travel on through the universe. And sometimes that's incredibly inspiring. And sometimes you think about the story that you're a part of. The water in my body has hydrogen from the Big Bang, from the very start of the universe. Then the oxygen came from stars that had to die. You hold your arms around yourself and you have a story that's billions of years and, trillions of miles across, just in your own self.
Stars have always had a special meaning for humans, but it's only relatively recently that we've started to understand these massive collections of stars known as galaxies in the distant parts of our universe. The James Webb Space Telescope was eagerly awaited by everyone in the field of astronomy, and we had high hopes for what it could reveal. We had specific expectations about what Webb would show us, and it was anticipated to be a game changer. And the most recent discoveries made by the Webb telescope have surpassed even our wildest expectations. It has truly exceeded the scale of what we believed it could accomplish. The size of galaxies is determined by various cosmic factors, like how old they are, how they were formed, and their interactions with nearby galaxies. When galaxies collide and merge, they can become even bigger, making it more challenging to comprehend their enormous sizes. But the James Webb Space Telescope takes us beyond what anything else has seen. The JWST has made an intriguing discovery. It has detected over 1,000 galaxies that share a striking resemblance to our own Milky Way, and these galaxies were found in the early universe. These look-alike galaxies, shaped like warped vinyl records and featuring delicate spiral arms, were observed by JWST more than 10 billion years into the past of our universe. This is a time when it was believed that violent mergers between galaxies should have made the existence of such delicate galaxies highly unlikely. Surprisingly, the research indicates that these disk galaxies were 10 times more common in the early universe than astronomers had previously thought. This discovery adds to a growing mystery about how large galaxies, which could potentially support life, first emerged in our universe. So now we have the information as the James Webb Space Telescope has provided surprising findings about the Milky Way center. It has revealed the presence of ice in unexpected locations. When we look towards the galactic center, we see a lot more stars, and the density of stars that is about 1,000 times greater than in our own solar neighborhood. However, there are dense dark clouds that can obscure our view, making it look like we see nothing, especially in visible light. With infrared telescopes, we can see through the dust and observe countless stars. JWST, with its superior resolution, allows us to resolve individual stars in this dense region. The galactic center is an important area to study, and JWST, with its infrared capabilities, is the right tool for the job. It can see through the dust and explore the structure of the stars and the material between them in this region. The hard question that remains is, how can we understand the vastness of the 92 billion light-year-wide observable universe when we're so small in comparison? This is an important question because when something seems incomprehensible, it becomes more distant and less relatable. Given that we are an integral part of the universe, we should feel at home within it. It becomes difficult making sense of the universe's enormity. We have to get very abstract. It's simply beyond what we're familiar with on a day-to-day basis, and beyond what our senses are capable of perceiving and making sense of. On Earth, our usual everyday experiences involve scales ranging from tiny millimeters to just a few kilometers. However, when we consider the universe, even just the part that we observe, it extends over a vast 92 billion light-years. We, as humans with limited understanding, struggle to grasp the vastness of the entire universe. These are mind-boggling scales. It's akin to an ant trying to fathom the distance between New York and California. So how can one wrap our heads around this concept? To many of us, thinking about the immense scales of the universe can be overwhelming. It's like trying to understand the incredibly small worlds within us, from the microscopic to the molecular and even subatomic levels. If you were to look at your body through a microscope, you'd find that it was mostly composed of cells. These cells work together in various systems to carry out essential life processes, and there are roughly 80 to 100 trillion cells in a typical adult human body. Cells, which are typically just tens of hundreds of microns in size, consist of smaller components like organelles, cytoplasms, and various molecules such as proteins and nucleic acids. These molecules are constructed from atoms, which are about 100 picometers in diameter. At the core of atoms, there are tiny electrons orbiting nuclei that are approximately 1 femtometer wide. Nuclei are composed of protons and neutrons, and these in turn are made up of minuscule quarks and gluons. It's known that electrons, quarks, and gluons are no larger than about 10 to the negative 19 power meters, and they might extend down to infinitesimally small scales. There are lots of intriguing and true facts about the basic building blocks of our world, but they can be hard to understand. For example, the human body, that is a complex and remarkable system composed of trillions of cells, which are the fundamental building blocks of life. The majority of a human body's mass is derived from approximately 4 trillion cells, which form our muscles, bones, connective tissues, and internal organs. An additional 40 trillion cells are the blood cells coursing through our body, while about 50 trillion are bacterial cells that reside in our digestive system, not produced by our body. In total, a human body contains nearly 10 to the 28th power of atoms and close to 10 to the 29th power of subatomic particles. These numbers are remarkably vast, roughly 10 to 100 million times more than the total count of stars in the universe. If you were to entirely fill the volume of an adult human body with, let's say, neutrinos, you could accommodate over 10 to the 43rd power neutrons, with a combined mass of around 20 trillion tons. Understanding scales that differ greatly from our everyday experiences can be daunting. This is why nature offers a helpful hierarchy that allows us to grasp these scales incrementally. At the tiniest level, quarks can be understood within the context of protons. Protons and neutrons, in turn, make up the nucleus of an atom. Atoms are familiar building blocks, forming molecules when they interact. Molecules are a bit larger and can assemble into organelles within cells, a manageable scale from a molecular perspective. Cells then come together to create the structures of bones and organs. Ultimately, our bodies, composed of cells, become accessible and understandable in terms of their composition. This gradual progression helps us navigate the vast scales of the universe. Starting with the scale of a human and moving up gradually can make understanding our universe more manageable. While Earth may seem enormous compared to an individual, it's not so daunting when we take incremental steps. Humans can climb mountains, and these mountains can reach several kilometers in elevation above sea level. If you venture higher in a hot air balloon or airplane, you can attain altitudes of tens of kilometers. Traveling on a spaceship allows you to escape Earth's atmosphere, reaching heights of hundreds of kilometers, which is similar to the view one would experience from the International Space Station. This stepwise approach helps us bridge the gap between the human scale and the vastness of our planet. As you move farther from Earth, it looks like a big ball that's about 13,000 kilometers wide. Even from a bit above the surface, you can see its round shape, and a few hundred kilometers away, you can see half of it at once. While Earth is huge compared to us, some people have gone far enough into space to see this amazing view. It's called the overview effect, and it's what made William Shatner cry when he went to space in 2021. It's a unique way to see our planet. The Earth is relatively small compared to other objects in our solar system. So in the vast expanse of our solar neighborhood, Earth appears rather diminutive in comparison. Our planet, while brimming with life and diversity, pales in size when juxtaposed with some of its celestial neighbors. Take Uranus and Neptune, for example, both of which loom over Earth with diameters approximately 4 times greater. These distant ice giants present a stark contrast to our modest world. Yet the scale of planetary grandeur truly soars when we direct our gaze towards the mighty gas giants, Jupiter and Saturn. These behemoths of our solar system make Earth seem positively minuscule, with dimensions about 10 to 11 times larger. Their colossal atmospheres, festooned with intricate patterns of swirling clouds and immense storms, serve as a testament to the magnificence of celestial bodies. And then, of course, there's the Sun, the unchallenged colossus of our solar realm. Its colossal diameter, a big 1.4 million kilometers, outshines everything else. To put it into perspective, the Sun outstrips Earth by a great 109 times, a fact that boggles the mind. One can scarcely fathom the sheer enormity of this celestial furnace. It's so immense that it could effortlessly contain over 1 million Earths within its fiery embrace. This makes us feel very small in comparison to the vastness of the universe. When we think about these objects from Earth's perspective, it's helpful to consider the scales at which they move in relation to each other, such as the distances between planets. Earth's average distance from the Sun is about 150 million kilometers, or 93 million miles. What's fascinating is that this distance is just a bit over 100 times the size of the Sun itself, which in turn is only a bit over 100 times the size of Earth. So when we step back and observe our solar system from beyond Earth's atmosphere, we're transitioning from the scale of an average 1.5 to 2 meter human to a massive orbit around the Sun, spanning approximately 150 billion meters. Indeed, our Sun is just one star among countless others in the Milky Way galaxy. To grasp the next significant step in scale, we can start from where we left off, focusing on the scale of Earth's orbit, and move on from the distances between stars in our cosmic neighborhood. Planets in our solar system orbit the Sun at varying distances. Jupiter's orbit is about 5 times larger than Earth's, Saturn's is 10 times bigger, Uranus is about 20 times greater, and Neptune is 30 times larger. Beyond Neptune is the Kuiper Belt, which extends twice as far as Neptune's orbit. If we continue outward, you have to travel about 1,000 times Earth's orbit to enter the inner part of the Oort cloud. The Oort cloud, on the other hand, stretches out for tens of thousands of times the distance from Earth to the Sun, perhaps even beyond a whole light year. Once you venture several light years away, you'll encounter the next closest star to Earth, Proxima Centauri, sitting 4.2 light-years away. Stars are really far apart, and we measure these distances in light-years. Within 25 light-years of us, there are hundreds of stars. If you expand that to a sphere of 100 light-years around Earth, you get more than 10,000 stars. At this scale, you can see that the Milky Way, our galaxy, has a structure. In the direction of the galactic center, in the plane of the Milky Way, and especially along its spiral arms, there are more stars, while in other directions there are fewer. The Milky Way is a galaxy, which is a huge collection of stars, but it's not unimaginably vast. It's a little over 100,000 light-years wide. To put it in perspective, if an average human lives on a 13,000-kilometer wide Earth, the ratio is similar to the distance to the inner Oort cloud compared to the size of the Milky Way. The idea is that the relationship between humans and Earth's size is like Earth's size compared to the inner Oort cloud, which is similar to the inner Oort cloud size in relation to the Milky Way. And believe it or not, it gets even simpler from here. Stars are really small compared to the next huge gaps between them. If we imagine the sun as a grapefruit in Seattle, Washington, the next closest star would be like a grapefruit all the way over in New York. Now, when we talk about galaxies, it's a whole different story. If we think of the Milky Way as a grapefruit in Seattle, Andromeda, the biggest galaxy in our local group, sitting 2.5 million light-years away, would be like another grapefruit in the same room, only about 10 feet away. Imagine the Virgo supercluster, which spans a vast 100 million light-years. It contains thousands of big galaxies, like having lots of grapefruits clustered together in groups over just a single city block. In the big picture of the universe, it's a bit like this. There are hundreds of billions of grapefruits, representing large galaxies, along with tens of trillions of smaller fruits, like oranges, mandarins, and kumquats, symbolizing smaller galaxy versions, and they're scattered around nearly 500 city blocks in all directions and dimensions, with our block, home to the Virgo cluster, right at the center. If 100 million light-years is well within our local supercluster, it's only about 460 times that distance to reach the edge of the observable universe. Going from the scale of a human to the scale of the entire observable universe is incredibly overwhelming. Humans are just a couple of meters in size, while the universe we can see stretches for about 46 billion light-years in all directions. This means the observable universe is almost 27 orders of magnitude larger in diameter than a human, which is a factor of 1 octillion. That's 1, followed by 27 zeros times bigger. It's easy to see why this is mind-boggling. To make this more manageable, we use 2 tricks. We don't take one giant leap from one scale to another. Instead, we take many reasonable steps, so no 2 steps are too far apart. We don't look at everything in the same way. We change our perspective with each step. To understand the vastness of the universe on different scales, think in logarithmic terms. Think of a universe map with a logarithmic scale that reveals its grandeur in one glance. This approach helps in grasping distances and sizes, making it easier to appreciate the immense scale of our cosmos. When thinking about scales as immense as the universe, it's better not to use the perspective of a human, but something more relevant to the cosmos itself. The universe is indeed vast, but it's only a few 100,000 times bigger than our Milky Way galaxy. The Milky Way is impressive, but it's only a few tens of thousands of times larger than the distance between typical stars. The gap between stars is sizable, but it's only a few 100,000 times greater than the Earth-Sun distance. And the Earth-Sun distance is just about 10,000 times the size of Earth, which is something we can relate to as humans. If we insist on making that huge leap from our scale to the size of the observable universe, it's easy to feel tiny. However, we're a part of many significant things that fit better on larger scales. We can see ourselves as beings of Earth, members of the solar system, components of the Milky Way, and residents of this vast universe. This isn't an inconceivably enormous place. It's our home as we know it, and the objects nearby and far away are our cosmic neighbors and family. Even though they may seem incredibly distant, from the universe's perspective, everything we can see is pretty much right next door. The vastness of the universe sparks a sense of wonder about its purpose. What's truly astonishing is that we're essentially made of stardust, but we're unique stardust. For some reason, we exist in this moment, contemplating the cosmos. We, the offspring of the universe, emerged from simple chemicals after billions of years, and now we gaze with curiosity into the boundless dark expanse, pondering its mysteries. The idea of inanimate matter evolving into life is a fascinating subject in its own right. The universe may just be starting to fathom its own existence, or perhaps We're merely one of countless intelligent civilizations out there. Regardless, I find it all incredibly fascinating, and I hope you do too. Now, if you enjoyed this video, don't forget to like and subscribe.